Humans, it's good to see your face again. Yes, I can see you. Weird. Also, we're going to be solving systems of equations with the substitution method. By now, you should have learned how to solve a system via graphing. You graph one equation, like so. You graph another equation, and wherever they intersect, that's where they share a solution. So that point, that ordered pair, x, y, is a solution for both equations. So our system is solved. It satisfies each equation in the system. That's what it means to be a solution to a system of equations. So let's look how we can solve a system using the substitution method. Wouldn't it be great to find a system of equations? Oh, I found one right here. Y equals 3x plus 2, and then we have x plus 2y equals 11. Here's our system of equations. What xy pairing, what coordinate point xy would work for both this equation and this equation? I don't know. You could graph them and figure out where the lines intersect. That would be the point that they both share, a solution they both share. But here's the substitution method. Let's go back to that handy-dandy little cheat sheet that I didn't even talk about that was there on the first page. Here's our little steps. Step 1, solve one of the equations for one of its variables. Well, by golly, it's already done for us in the first equation. Y equals 3x plus 2. So one of the equations is already solved. That's step 1. Step 2 says substitute the expression from step 1, that's this, substitute that in to the other equation and solve for the given variable. Okay. Well, what I like to do is read this sucker a million times. Y is 3x plus 2, y is 3x plus 2, y is 3x plus 2. And then I start to write the other equation, x plus 2, wait, y, instead of writing this y, I'm going to write what y is. As I just mentioned 1,000 times, y is 3x plus 2 from the first equation. So instead of writing y here, I'm going to write what y is. Y is this 3x plus 2. So I've substituted it in to the second equation, and now I'm going to solve for the only variable that exists now. 2 times 3x and 2 times 2. How about 6x's and how about 4 is the same as 11. Combine like terms if you got them. And you can see 7 equals 7x. How about x being worth 1? Step 2, complete. Step 3 says substitute the value from step 2. That's what we got here. Substitute that in the revised equation from step 1. Well, the revised equation was the one that was already given because it was already solved for a given variable, y. And now we've got x to be 1. So instead of x, let's make that value what we found it to be and solve for y. 3 and 2. Looks like 5 is what y is. And you can have one final statement that says your x value is 1 as found over here, and your y value is 5 from step 3. The solution to this system of equations is the point 1, 5. And you can always check yourself. You can take this information, put it back up here into either one of these equations, and it should be true. Sweet. Let's try another one. Okie dokie, here we go. We've got a system of equations here, and good thing we have our handy dandy cheat sheet that tells us the steps. Let's see what we can do. Step 1, solve one of the equations for one of its variables. Nothing is solved already for one of its variables. But pay attention to the latter part of this first step. When possible, solve for the variable that has a coefficient of 1 or negative 1. So as I'm looking up here at this system, I look at this lonely x. This x has a coefficient of 1. So I'm going to try to get it by itself and rewrite this system. If I leave that x by itself, by adding 2y to each one of these sides of the first equation, I can come up with a new improved form for the first equation. X is equal to 2y minus 6. The second equation remains unchanged. And this is the same exact system, except for now the first equation is written a little more helpful. Let's take a look at the second equation. We're done with step 1. If you take a look at the second equation, but instead of writing this x, what I want to do is make sure I put what x is. And I just made a statement with the first equation that is x is 2y minus 6. So instead of this x in the second equation, I'm going to put what x is. X is 2y minus 6. And I write the rest just as it is. Here we have it. And now I can solve because it has a single variable. 4 times 2y and 4 times negative 6. 8y minus 24 is plus 6y is 4. Combine any like terms that you might have. 14y minus 24 equals 4. Add 24 to both sides. And you can see that 14y is equal to 28. Therefore, y is 2. Step 2, complete. Step 3 says take a look at that second equation. The original equation that you revised, this one here. And you've got x equals 2y minus 6, but you just learned what y is. Y is 2, so let's put that 2 in. And this will show you the value for x. 4 minus the 6, so x must be negative 2. Y is 2, x is negative 2, y is 2. There's your solution for the system of equations. Negative 2, 2. If you wanted to check it, you can take that and put it back into the original 2 equations and make sure it works for both. Woo, this is fun. I want you to try the next 2 systems that I show you. Try to solve them with substitution. Humans, you will try these for your homework and show me tomorrow. Use the substitution method. If you need the steps, there they are, and they're really small. Now they're a little bigger. And I'll just cover the try these. So try these. Here's your steps for helpful hints. Illy.